Every summer, my family and I travel across the world, 3,000 miles away, to the country diverse country of India. Now, India is a country infamous for discording heat and humidity. For me, the only relief from the his heat is to drink plenty of water. Now, while in India, my parents always remind me to only drink boiled and bottled water, because unlike here in America, where I can just turn on a tap of easily get clean potable water. In the India, the water is often the contaminated. So my parents have to make sure that the water we drink is safe. However, I soon realized that not everyone is fortunate enough to enjoy the clean water we did. Outside my grandparents' house is a busy streets in India. I saw people standing in long lines under the hot sun, filling buckets was water in. I even saw children who looked the same age as same, filling up these clean plastic bottles with dirty water from streams on the roadside. Watching these kids forced to drink water that I felt was too dirty to touch changed my perspective on world. This unacceptable social injustice compelled me to, to want to find a solution to our world's clean water. I wanted to know why these kids lacked water, a substance that is essential for life, and I learned that we're facing a global water crisis. Now, this may seem surprising as 75% of our planet is covered in water, but only 2.5% of that is fresh water, and less than 1% of Earth's freshwater supply is available for human consumption. With rising populations, industrial development, and economic growth, our demand for clean water is increasing, yet our freshwater resources are rapidly depleting. According to the World Health Organization, 660 million people in our world lack access to clean water source. Lack of access to clean water is leading case in children under the age of 5 in developing countries, and UNICEF estimates that 3,000 children die every day from a water-related disease. So, after returning home one summer in 8th grade, I decided that I wanted to combine my passion for solving the global water crisis with my interest in science. So, I decided that the best to do would be to convert my garage into a laboratory. Actually, at first I converted my kitchen into a laboratory, but my parents didn't really approve and killed. I also read a lot of journal papers on water-related research, and I learned that country in something called a solar disinfection or sodas is used to purify water. Sodas, clear plastic bottles, are filled with contaminated water and then exposed to sunlight for 6 to 8 hours. The UV radiation from the sun destroys the DNA of this harmful plants, and this decontaminate the water. Now, while sodas is really easy to use and energy efficient, and it only uses solar energy, it's really slow, as it can take up to 2 days when it's cloudy. So, in order to make the sodas process faster, this new method called photocatalysis has recently been used. So, what exactly is the photocatalysis? Photo mean from the sun, and a catalyst is something that speed up a reaction. So what photocatalysis is doing? It's just speeding up this solar diffraction process. When sunlight comes in a streak and photocatalysts like 2IO2 or titanium dioxide, it creates these really reactive oxygen species like superoxides, hydrogen peroxide, and hydroxyl radicals. These reactive oxygen releases are are able to remove bacteria and organic and the whole lot of contaminants from drinking waters. But unfortunately, there are several disadvantages to the way photocatalytic coatings is currently developed. See, what they do is they take plastic bottles and they coat inside with this photocatalytic coating. But photocatalysts like titanium dioxide are actually commonly used in sunscreen to block UV radiation. So when they're coated of on inside these codes, they're actually blocking some of UV radiation and diminishing the efficiency of process. Also, these photocatalyst coatings are not tightly bound to plastic bottles, which means they wash off and people end up drinking the casting. While TiOx is too is safe and rent, it's really efficient if you keep because then you have to continue to replenish it if even after a few uses. So my goal to overcome the disadvantages of this current treatment method and create a safe, sustainable, cost-effective, and eco-friendly method of broadly what started off as eighth grade science birth is now my photo catalyst composite for water competitions. The composite combines titanium dioxide with cement. This cement-like composite can be formed into several different shapes, which result in an extremely of the for example, you could create a rod that can easily be placed inside water bottles for individual use, or you could create a porous filter that can filter water for families. You can even coat the inside of existing water tank to purify large amounts of water from communities over a longer period of time. Now, over the course of this, my journey hasn't really been easy. Now, you know, I didn't have access to sustainable. I was 14 years old when I started, but I didn't let my age deter me in my interest in biting scientific research. I wanted to solve a global water crisis. See, water isn't just universal. Water is universal human right, and for that reason, I continuing to work on this science fair project from 2011 to bring it from laboratory into the real world. And this summer, I founded Catalyst for World Water, a social enterprise aim is catalyzed solution to global water crisis. Alone, a single drop of water can't do much. But when many drops come together, they can sustain life on our planet. Just as water drops come together to form oceans, I believe that we all must come when tackling this global problem. Thank you.